Hey guys, this is Miss Williams. So I am home on a snow day, and so I've got my kids here with me. Be advised, you may hear things. I'm going to try to make a quick video to help you guys with the molar mass lab. I am not doing the lab for you, but I am going to talk to you about the common problems that I run into with the lab, and I'm going to show you, I'm going to walk through the questions on the lab so that you have a better idea of what you're trying to calculate there. Okay, so with the molar mass lab, it is all about colligative properties, and those are pretty heavy in chapter 13. So chapter 13 talks about how if you have a solution and you add something to it, some kind of solute to it, then it changes certain properties. One of those properties is freezing point. It lowers the freezing point, and we call that freezing point depression. And so we're going to be calculating that today. One of the first things that you're going to do in the lab is you're going to make a cold water bath that we're going to use to then measure the freezing point of 4 different solutions. Okay, so you make your cold water bath in your large beaker. Water normally freezes at 0 degrees Celsius. So if you just had ice water here, hopefully you're going to measure the temperature at 0 degrees Celsius. We want to drop that temperature by 10 degrees. So we're going to do that by adding salt to the water. We're using a colligative property to make our ice bath. Okay, so once we add the salt to the water, a lot of times what I have found is if you can't get the water cold enough, it might be that your ice has melted. So what you want to do is make sure you keep plenty of ice in there and make sure you've added the appropriate amount of salt, and your temperature should drop to around -10 degrees Celsius. Okay. Once you get that, we're going to be testing the freezing point of 4 different solutions. Okay, so we're going to be you've got 4 test tubes. I did want to show you what your test tube rack looks like once you get it put together. There's a lot of folding going on here. So this is what your test tube rack ends up looking like. If you'll fold all those perforated areas and kind of pop things in, you end up with this. Okay, so you have 4 different solutions. Those 4 different solutions, I have a list. The first one is going to be water. Okay, so test tube 1 is going to have 15 milliliters of water. Test tube 2 is going to have 5 milliliters of glycerol, which is in a little bottle in your kit. So 5 milliliters of glycerol and 25 milliliters of water. Test tube 3 is going to have 25 milliliters of water and 2 grams of sodium chloride. And then test tube 4 is going to have 25 milliliters of water and 2 grams of calcium chloride, which comes in this little thing that was part of the molar mass aspect of the kit. Okay. And so for each one of those, you're going to be putting it down into the ice bath and watching the temperature and trying to figure out when you have freezing taking place. One thing to look for, your temperature is going to, like when you first put it down in the ice bath, your temperature is going to start to drop. When that temperature levels off and kind of quits dropping, that's probably when your freezing point takes place, because remember, temperature does not change during a phase change. So that's one thing to keep an eye out for to help you know when freezing is happening. Okay, so you're measuring the freezing point of these 4 different solutions. Okay, so what I want to do now is I am going to pull up your lab workbook. This is the thing that you're actually turning in, and I'm going to share my screen. Okay, so here is your lab workbook. It has a few pre-lab questions that you're going to go through and answer. These normally go pretty well for students with one exception. This, in number 3, they use a really obscure word that is unfamiliar to most of us and does not show up in your textbook. So it talks about the number of osmoles, okay? They're asking about the Van Hoff factor. Okay, so for us, we've been calling that the Van Hoff factor. That is looking at the number of particles that your substance breaks apart into. Okay, so then they give you a place to record your freezing points. Okay, for all of your solutions, water is your solvent. So this first one is kind of like your control. That's telling you what the water froze at. And then we're adding these things to some water to see how much it dropped the temperature by. Okay. Now, the next portion is where we are doing some calculations. And so this is where I usually see a lot of questions come in. So let me kind of talk you through some of these calculations just a little bit. I got to get my Zoom menu out of the way so I can use my pen. Okay. Marshall, go play. All right, so with these calculations, we're trying to find the molar mass of each compound. So one thing that we need to know, well, for freezing point depression, the formula that you use is delta T equals negative I K little m. Okay, so let's talk about this formula just a little bit. The delta T is the change in temperature. You had your original temperature, freezing temperature of your solvent. How much did that change by? So in our case, the original temperature is whatever our water froze at, and then we're looking at how much each one of these changed by. That gives you your delta T. Now, when you look at this formula, the I value is talking about the solute, the thing that you are dissolving. So that I value is the number of particles that it breaks apart into. If you've got an organic particle or something that is a molecular compound, which typically is something that we, so glycerol is an example there. If you've got a molecular compound, it's going to stay together as a molecule, and your I value is going to be 1. If you have an ionic compound, it's going to break apart into its ions when it dissolves, and so your I value is the number of ions that it breaks apart into. I'm going to do a random example like Al2O3. When that breaks apart, it's going to break apart into 2 aluminum ions and 3 oxygen ions. So that's a total of 5. Okay, so that would be your I value for that. Now, your K value is about your solvent. In all of our examples, water is the solvent. Okay, so you can look up the K value, and I think it's in the lab tabs. Like when you go through those tabs of the lab, I think you'll find the K value. And then the M value, the molality, is about the total solution. Okay, so the total solution. So just a little overview of the formula that we're going to be starting with. We're going to be using this formula to calculate the molar mass of each compound. And we have to do a couple of steps in there. Okay, so the delta T we're calculating during the lab. The I value, I think you can figure, I think I've given you enough information to figure out. The K value, you look up. We can solve for the molality of the solution. We're going to be able to use that molality to calculate a molar mass for each of these compounds. Okay, so like this step, when it asks you for molar mass, they're not asking you to look at the periodic table. They're asking you to calculate a molar mass. Okay, so the first thing that you want to do is solve for the M value. Plug in this information and solve for the M value. Then think about what molality is. Molality is moles of solute over kilograms of solvent. Okay, so moles of solute over kilograms of solvent. Okay, so this molality value you just solved for. Kilograms of solvent, you know how much water you added. Water has a density of 1 gram per milliliter. So if you added 25 milliliters, you added 25 grams. You can figure out the kilograms of solvent. That allows you to find the moles of solute. Okay, now we're getting closer because what a molar mass is grams per mole. So we have the mole value. The gram value is however much you measured on your scale. So like for the sodium chloride and the calcium chloride, the amount that you measured on your scale is your grams. You divide it by this mole value you just solved for, and it gives you the molar mass. In the case of glycerol, getting the gram value for glycerol is a slightly different process because glycerol is a liquid. You would want to take the volume of it that you measured and use the density to find the grams. The density for glycerol is 1.26 grams per milliliter. Okay, so if you can use that information, you can find the grams. Okay, so there's several steps here. You're plugging into here to solve for molality. Then you're coming to this formula to find moles, and then you're using your actual amount that you used to do grams divided by moles. That's going to give you the molar mass. Okay, then I think the rest of this is a little bit more self-explanatory. Once you find those molar masses, you're comparing them to the molar masses off the periodic table, and then just discussing some things. Okay, so those are the major questions that I get out of this lab. I hope that this has been helpful, and please email me or send a message to your class. You guys are welcome to work on these labs, to ask each other questions about these labs as you go. So y'all have a great day. Bye.